In this video, we will talk about the fragmentation issues. The contiguous memory allocation method suffers from the external fragmentation issue. As processes are loaded and removed from the memory, the free memory space is broken into little pieces. External fragmentation exists when there are enough total memory space to satisfy a request, but these available memory spaces are not contiguous. So the memory space is fragmented into large number of small holes. These small holes cannot satisfy the request. For example, suppose there are 6 variable sized holes, 300 KB, 600 KB, 350 KB, 200 KB, 750 KB, and 125 KB. And now a process requests 900 KB of memory space. Now we check every hole available memory space. There's no hole that is big enough to satisfy this request. But if we can combine these 6 holes together, so the 750 KB plus the 200 KB, if we can combine these holes together, this request can be satisfied. Okay, this is the external fragmentation. The analysis shows that given unallocated blocks, another 0.5 n blocks will be lost to fragmentation. So we can see the external fragmentation problem can be severe. The 1/3 memory space may be unused. Now, to reduce external fragmentation, we can compact the memory content. That means shuffle memory content to place all memory holes together to form a large hole. So we merge all these 6 holes together and we form a large hole to satisfy the request of this process. This is the external fragmentation. We also have the internal fragmentation. Internal fragmentation means allocated memory space might be slightly larger than the requested memory space. When the operating system allocates memory space to a process, the basic unit is not byte. So memory is not allocated by byte. So there's typo here. The memory is not allocated by bytes. Normally, the memory space is divided into fixed sized blocks. For example, the one block consists of 512 bytes. And the memory space are allocated in units based on block size. For example, the block size is 512 bytes. A process requests 2,000 bytes. So the operating system will allocate 4 blocks to this process. 4 blocks, 4 times 512. That means 2,048 bytes is allocated to this process. But the process only needs 2,000 bytes. So the 2,048 minus 2,000, these 48 bytes are unused. Now this process never uses 48 bytes. That means the allocated memory space is slightly larger than the requested memory space. So the 48 bytes are unused. This is the internal fragmentation. The contiguous memory allocation suffers from the external fragmentation and internal fragmentation. This video will stop here. We will talk about the non-contiguous memory allocation to avoid the external fragmentation.